I'm Lachlan. I'm here to talk about a library that I've written, which I thought might be useful for some people out there. So can I just get a show of hands? Who knows what JSON is? And does anyone, who has used the Gson library to parse JSON? Cool. All right, that's good. All right, so my name of my library is called Gson Path. Pending name change potentially. As all libraries are, you kind of pick the first one and it kind of sticks. Maybe this one shouldn't stick. So, what is the current state of Gson? So it's a very popular Java library for converting Java objects to and from JSON. It's written by Google. There's plenty of external contributors who work on it, and it's nearly 8 years old. Gson uses reflection quite heavily to create mapping classes. So it actually creates these type adapter classes which define how data is serialized and deserialized from JSON. And so the initial construction of that type adapter, Gson actually iterates through all the fields which are exposed in your Java class, and then it constructs this type adapter, which it then uses after it's cached it to actually serialize and deserialize. So because it's using reflection, the initial creation of this type adapter can be relatively slow, and each type adapter is actually cached on a particular instance of Gson. So they kind of recommend that you should reuse your Gson instance, which kind of means that you have to carry around your Gson instance everywhere. Maybe you've got to make it a singleton or something, so it's got to kind of be everywhere. So what are some of the problems I have with Gson that I'm trying to solve here? So as I mentioned, there's quite a lot of reflection happening, which I'm not that happy about. There's a relatively large performance cost compared to reuse. And then another problem I had was if you have a very complicated nested JSON structure, you have to actually basically create Java objects to map to each individual JSON object. So if you have a really complicated JSON structure, you end up having to create a very complicated hierarchy of Java objects, which can get quite annoying. Like so. And then there's a way of getting around that where you can actually write your own custom type adapter to actually map data in such a way that you like. But writing code like that is really cumbersome, and you don't really like doing that all the time. And then other things is because it's being done in reflection, it's not debuggable, and then it also doesn't work very well with ProGuard if you use field name obfuscators. So when you actually compile your code, Gson will try and use reflection to actually get the name of the field from the Java object, but if you've used an obfuscator, it doesn't correctly get the field. So to actually counteract that, you have to actually annotate every single field in your JSON object with a serialized name, and then it uses that instead. So that's kind of what you have to do there. So what is my library? It's an annotation processor, similar to Butterknife, AutoValue, Dagger 2, and it's kind of designed to resolve a lot of the problems I've mentioned in the previous slide. So interestingly, in my slides, I kind of jumped to the end, but kind of my end goal that I kind of wanted to have was you potentially create a Java class like this, and you just add this annotation here. And with the annotation processor, it actually generates Java code over here, which I've kind of truncated to actually look nice in the projector. So it'll actually go through, create your object, iterate through all the fields in the JSON, and it will correctly map the value, and it'll correctly get the string and do it safely, because normally Gson will actually throw an exception if you try and obtain a string which isn't there. So the other problem regarding nesting, so potentially if you've a JSON, like an example here, so there's a degree of nesting here. So normally what you'd have to do is you'd have to create classes such as these. So you'd create like a container object which would just have the single node here, and then that is a class of store model, which then contains information about the owner and then the address, and then so on. So you end up getting 4 classes you have to write here to actually get it to map nicely. So I didn't really like doing that. Where I'm working at the moment, there's quite a lot of these overly unnecessarily nested JSON files. So any way that I can reduce the amount of POJOs I have to write is great. I don't actually have this in the slides, so in any of the slides, so I'll just kind of mention it as well. So there's a library which I'm also quite, which I use quite a lot, called dbflow. So it's a ORM annotation processing library which will actually also generate boilerplate code. And if you actually have a very flat structure, it'll actually generate boilerplate database code. And then as long as you have primitive types and strings, it'll actually automatically map information into SQLite database. So ideally, I would like to be able to take this JSON here and insert it into a single table without writing any code. So the solution, so with the previous JSON file here, so as an example over here, so I'm annotating it with this annotation of my own. I give it a root field, so I tell it that it needs to start here. So it'll actually recursively get to this position, and then I'm using the default Gson annotation at the moment for serialized name, and I've given some very, very basic XPath or Gson Path support. So you basically give it decimal place dots to the particular element in the JSON, and the annotation processor will correctly create all the nested code. And then, yeah, so happy. So a lot less code to write, a lot more maintainable. It's been flattened into a single class, and then depending on how many of these objects you actually need to pull into Java, potentially you've got an array of like 50,000 of these. If you've got to create, I won't bother going back, but if you have to create 5 of those objects each time for each individual node there, having a single class is obviously more memory efficient there. So this is an example of the code. Once again, it's kind of been clipped, so it fits in to the page, but basically it'll iterate through all the JSON and then go to a particular element. And then here it knows that it's another object, and it just begins to traverse down the JSON tree. And then when it gets to the first name, it correctly assigns it to the correct variable. And it's been altered a little bit, so there's some other type safety that's normally in this code, but I've excluded, so I can actually fit at least this amount of information. One thing that's quite nice about this is that because it's being done using an annotation processor, it's actually getting the names of the fields before ProGuard runs. So you don't actually have to use the serialized name annotations on every single field, because the annotation processor actually grabs it from the code before it's actually been obfuscated. So there's no issues there. So it's a lot better to use with ProGuard. So even if you don't actually want to use it for any of the other reasons, the fact that it plays nicely with ProGuard is a nice feature. And that was actually an inadvertent feature which I wasn't, there was actually no reason I wasn't planning on doing that, but it just happened to be the thing, so that's cool. And then code looks a little bit ugly because it's doing quite a lot of nested while loops, but it's actually no different. I tried actually flattening it and doing it in a single while loop, but in terms of computational complexity, it's basically the same thing. And then if you so choose and you're using the APT plugin, you can actually debug this code and run through each element as you see fit. So potentially if this type adapter here needs to work for different JSON files, you could see why it's not working for a particular JSON file, which could be quite nice. So in terms of performance, I got some performance improvements out of it, so I thought I'd share it. So I've got a fairly basic scenario here. So I've used the previous example in the JSON, and I've basically put it in an array of 50,000 elements, which are all the same. And then I'm using standard Gson and then the enhanced Gson Path class. And then I'm taking note of the initial execution time and then an average. And then for a reasonably consistent benchmark, I'm actually reusing both Gson and the Gson Path instances themselves. So ordinarily, if you were to recreate Gson every single time, you would end up obviously losing your cached version. So in terms of actually having a comparable benchmark, I'm using the same instance. As we see. So here's just some test case code I have here. And I kind of have lobbed off the actual initialization of the structures there. So 50,000 times down here. And then in terms of performance benefits, as you can kind of see here, the very initial execution time is reasonably faster. It's gone down from 200 milliseconds to 124 milliseconds. It can actually be faster than this. It's just that the way Gson actually goes and tries to find a type adapter, it actually has to iterate through every single type adapter. But a benefit is a benefit. And then the average is a lot closer because once Gson's actually created that type adapter, it's still a very efficient type adapter, so there'd be much of a muchness there. So in conclusion, the issues that I mentioned in the previous slide, much further back, have all been solved to some degree. There's no performance hit of using this. There's actually some degree of performance improvement. And that performance was based off a reasonably simple JSON file. The larger the JSON file and the more complicated the structure means less objects are being initialized, so potentially it would be a lot better. It depends. And then I'm still working on it, so there's quite a lot of things to do. I don't have a .4 here, but I haven't explicitly gone and checked that it works with Kotlin. So who knows, maybe I'll get an issue raised. One thing that's missing at the moment, so I've talked about deserialization, so converting JSON into Java. Currently there's no support for writing Java into JSON, which would be quite nice to go from one to the other. I'm still working on the documentation, and there's still some features that are missing, which I'd like to add. Cool, so here are the links. Feel free to have a look at my GitHub. At the moment, I haven't published a Maven artifact. I'm currently using Jetpack, planning on putting it up on Maven or Sonatype at some stage. Thanks a lot.